Hey guys, today we're learning lesson 8.3, which is on trigonometry. So first things first, trigonometry means the study of triangle measures. So we're only dealing with triangle right now, and we're dealing with measures and ratios. The next important definition is a trigonometric ratio is a ratio of the lengths of two sides of a right triangle. So a couple important things here. A ratio means that we're going to have a fraction of some kind. You're going to have one number over another number. It always deals with two sides, and it always deals with a right triangle. Has to be a right triangle, never not a right triangle. I'm going to write always next to it. Maybe a little nicer. Always, always a right triangle. Okay, what we have here, we have an example with a triangle XYZ. And for every acute angle of a right triangle, we can define trig ratios. It only works with my acute angles. It can never be 90. It's always one of the other angles, never 90 degrees. So we're going to focus on angle X right now. Whenever we decide what angle we're focusing on, I'm going to circle it in my diagram because that's kind of the lens that we're looking at it, as if we're standing at angle X, everything is in reference to angle X. Okay? So we've got three different trig ratios: sine, cosine, tangent. These are important. You get to them later, like in pre-cal on a regular basis, and so we're just in our introductory station of these. When you find sine, it's the ratio of the length of the leg opposite to x and the hypotenuse. So we call it opposite over hypotenuse. Let's first label my triangle, okay? So I'm going to use this red and I'm going to label it. I always start with my hypotenuse because that's the side that's across from your right angle, and I label with an H. Next, we take the angle that we're looking from, angle X, and we're going to go across from it. That's the opposite side, O. So I'm going to use a little O to represent that. And then the last side is the adjacent side. It's adjacent because it's next to the angle X. I think it's the harder one to recognize on its own, so I always do O and H first to make sure I know where those are, and then the last one just has to be adjacent. So if we have labeled our sides, O, A, and H, sine is the ratio of the opposite over the hypotenuse. So in this case, my opposite is x and my hypotenuse is z. So sine of angle x is x over z. That's it. It's a ratio. Leave it as such. Okay? Now we're doing, oh gosh, stop. All right. Now we're doing cosine. Cosine is a different ratio. It's now adjacent over hypotenuse. So my hypotenuse is still on the bottom, but now we're looking at our adjacent. So we're doing y over z. Again, leave it like a fraction. Y over z. And then last is tangent, and that's opposite over adjacent. Opposite in this case is x over adjacent, which is y. Okay. If we had actual numbers here, we're going to simplify them down and we'll see what that looks like in a second. But as of right now, we just have variables, so we're just using variables to represent this. I do want to teach you a quick shortcut. So some teachers will call it SOHCAHTOA. SOHCAHTOA. And that's something some students like to write at the top of their pages when we're doing this trig stuff because it's an easy way of remembering what's going on. So is sine, and sine is opposite over hypotenuse, as we demonstrated right there. Ca is cosine, which is adjacent over hypotenuse, which again we represented right there. And the last is toa, which is tangent over, which equals opposite over adjacent, which is right there. The biggest thing is that you spell it correctly. So, S-O-H, ca, C-A-H, and toa, T-O-A. So I'm going to write that on our page to help us remember this, but we can always come back to this slide and see what's going on to help us know what all of our trig ratios are. All right? Before we do a real example with numbers, I want us to remember about similarity of triangles. So by angle-angle similarity, a right triangle with a given acute angle measurement is similar to every single other right triangle in the world with that same acute angle measurement. So that's why trig ratios are constant for any angle measure. So if I'm looking at sine of 35, any triangle that has an angle 35 will have the exact same sine 35 because all of their ratios are the same because of similarity. So the reason this works is because of similarity. We're not going to have to prove this. We're not going to really look at it again. It's just know that that matters. Okay? The next example is ABC, and we have to find sine of A, cosine of A, tangent of A, and then all of those of B, sine B, cosine B, tangent B. Okay? So I'm going to start in red, and I'm going to circle angle A because that's the one that's our focus right now. Our first step is always to label my triangle. So I'm going to label my hypotenuse first, which is across from the right angle, so 15 is my H. In this case, my opposite is across from A, which means 12 is my opposite, and then the last one has to be A, so 9 is my A, my adjacent. So now I'm going to do sine of A. Sine of A, let's remind ourselves, SOTA, TOA. Sine is so I'm doing opposite over hypotenuse. You don't have to write that. I find it helpful when you're beginning. Opposite in this case is 12 over hypotenuse, which is 15. And in this case, we do have to simplify down because those have a common factor. 12 and 15 both have a common factor of 3, so I've got 4 over 5. All right, then I've got cosine. Cosine is adjacent over hypotenuse. Adjacent is 9, hypotenuse is 15. 9 and 15 have a common factor of 3, so it becomes 3 over 5. Try and square those so you see that they're different. 4 over 5, 3 over 5. And then last is tangent. Tangent is opposite over adjacent. Opposite in this case is 12 over adjacent, which is 9. They both have a common factor of 3, so I've got 4 over 3. All right. Now we're looking at B. So I'm going to change my color, so now I'm going to focus on B. Not everything changes, but a couple key things do. The one thing that doesn't change is my hypotenuse. My hypotenuse is still across from my right angle, so H is still 15. That does not change. However, my opposite now changes because the side opposite B is 9. So that's now an O, not my A. And then that makes 12 my A in this case. So everything I'm doing is in blue because I'm now on angle B. Even though the sides change, my SOHCAHTOA is still consistent. So sine of B is still O over H. Just O in this case is 9 over 15. So 9 over 15 is 3 over 4. We've already simplified that, so we're not going to slow that down. Next, I'm doing cosine, which we know is A over H. A in this case is 12 over H, which is 15. And that simplifies down to be 4 over 5. And then last, we have tangent. And tangent is O over A. O over A is 9 over 12. And that simplifies down to be 3 over 4. All right. Now, one thing I do want us to take note of is a pattern. Sine of an angle is the same as blank of the other angle. So sine of angle A, that's the same thing as cosine of angle B. And do you remember how angle A and angle B are related to each other? They are complements because they both add up to 90. A plus B equals 90 because in a right triangle, A, B, and C all add up to 180, but we already know C is 90, so then that means A and B both have to be 90 as well. All right, so now we're going to move on, and we're going to look at our calculator. So you should have a calculator out. I don't have a calculator to pull up on my screen, but make sure that you're in degree mode If you have a calculator that's yours, that's never been used for anything else, it should already be in degree mode. And if you have a question, get on Google Hangout with me tomorrow and we can figure out if you're in degree mode or not. Or if you plug in these numbers and you get different answers than me, then you are not in degree mode, and we can figure that out face to face. So first thing, you got to be in degree mode, and then when you enter things into the calculator, we want to round to 4 decimal places when necessary. 4 decimal places when necessary. So first thing we're going to type in, press sign. There's a sign button on your calculator, and then type in 30, end your parentheses, and then we get 0.500. There's nothing after 0.5 in your calculator, but we're going to have significant figures, which I believe you're learning in chemistry, so we got to put zeros behind it to get up to 4th decimal places. Then you're going to enter cosine of 30. Exact same thing. Press the button that says cosine, 30, end your parentheses, and this time I get 0.8660. Same thing. Tangent of 30, tan 30, end parentheses, and I get 0.5774. Okay, pause this video for a second and try sine, cosine, and tangent of 60. All right, welcome back. I got 0.8660, I got 0.5500, and then I got 1.7321. Recognize, like we just mentioned, the sine and the cosine are opposite each other. Remember that 30 and 60 are complements because they both add up to 90. So what we just proved last step is the same thing here. How fun. Okay, now we're going to do an example. We need to figure out what x, y, and z all are. We're going to find them using our trig functions. This is what we call solving the triangle. So if I give you like a worksheet or a problem on like a quiz or something and it says solve the triangle, it means find all of the angles, find all of the sides. I have to give you 3 pieces of information, but from then you can find everything else. So easiest thing to find, I think, is angle z. If we know it's a right triangle, or we know it's any kind of triangle, then all 3 angles have to add up to 180. So I have z plus 36 plus 90 equals 180. We'll add up 36 and 90 and minus that from 180, and I get z equals 54. That was easy. Okay. Then what we can do is, I would probably use the angle that was already given to me in case I messed up angle z for some reason. I'm going to use 36, and I'm going to find x, and I'm going to find y. Before I do anything, I have to label my triangle. I'm going to go, okay, here's my hypotenuse, here's my opposite, and then my adjacent is the one that's left. If I'm trying to do x, y, and z, or sorry, I'm just trying to find x, I have x, and then I have 8. I can't use y because if I use x and y, then I don't have anything to solve for. I can only have one variable in any equation. X and y, or x and 8, excuse me, are both O and H. So which trig function is that? Well, if I don't remember, I'm going to go back and look at SOHCAHTOA. Good thing we already labeled our triangle. O and H are both sine. So in order to find x, I need to do sine. I'm going to do sine of 36, sine of my angle, equals opposite over hypotenuse. We plug it into our sine equation, and then to get y by itself, we just use basic algebra. Multiply by 8 from both sides to get rid of it. So I've got 8 sine 36 equals x. I wrote it this way because you can literally just put this right in the calculator. 8 sine 36, parentheses, enter, go. And then I get 4.7 equals x. It says round to the nearest tenth, so that's what I'm doing. Okay. Now that I found that, I don't even need to use that. I can find y without that. If I want to find y, and I want to use the angle that was already given to me, and I want to use a side that's already given to me, which trig function am I going to use now if I'm going to use y and 8 for 36? I'm going to use cosine. Cosine of 36 equals y over 8. Again, algebra, multiply by 8 on both sides. 8 cos 36 equals y. Put that into your calculator, 6.5 equals y. You also could use Pythagorean theorem, but this is practicing what we learned today. So I'm going to pause here and then click on the next video to see more examples.